Quarter 4, test number 2 review, sections 8.6, 8.7, and 9.1. For 8.6, the first 9 questions, we are converting from degrees to radians or from radians to degrees. So if we look at number 1, we have 5 pi over 12. In order to convert this into degrees, we are going to multiply this by 180 over pi. So this 12 and this 180 are both divisible by 12, and we're going to get 1 and 15 when we simplify these. So this is going to be a 1, this will be a 15. Those pi's will also simplify to where we just have the 5 times 15, which is 75 degrees. For 215 degrees, we're going to multiply this by, or put it over 1 and multiply it by pi over 180. So the 215 and the 180 are both divisible by 5. The 215 divided by 5 is 43, and the 180 divided by 5 is 36. So this is just going to be 43 pi over 36. For 3, we have negative 29 pi over 18, so we're going to multiply this by 180 over pi. Those pi's simplify, though 18 becomes a 1, the 180 becomes 10, so it's just negative 29 times 10, which is negative 290 degrees. For 4, we're given negative 180 degrees, so we're going to put this over 1 and multiply it by pi over 180. So the 180s are going to cancel, so it's going to be negative 1 times pi, which is negative pi. For 5 pi over 3, we're going to multiply this by 180 over pi. Those pi's are going to cancel. 3 goes into 180 60 times, so it's 5 times 60, which is 300 degrees. For 6, we have negative 7 pi over 6. So we're going to multiply this by 180 over pi. Those pi's cancel. The 6 becomes a 1. The 180 becomes a 30. So it's negative 7 times 30, which is negative 210 degrees. For 10 through 15, we're using the unit circle to find the exact value of each trigonometric function. We are finding all possible values of each expression for 1 through 6. Change for number 7. Yes. Evaluate each inverse trig function. Give your answer in both degrees and radians. So these are the ones that are the second page. For number 7, we're given 400 degrees. So we're going to multiply this by pi over 180. So the zeros can simplify. The 40 becomes 20. The 18 becomes 9. So this is 20 pi over 9. For 8, we have 3 pi over 10. So this is going to multiply by 180 over pi. Those pi's are going to cancel. The 10 becomes a 1. The 180 becomes 18. So it's 18 times 3, which is 18 times 3, 54. 54 degrees. For 9, we're given 35 degrees. We're going to put this over 1, multiply it by pi over 180. The 35 and the 180 are both divisible by 5, so the 35 is going to turn into a 7, and the 180 turns into a 36. So this is just 7 pi over 36. For 10 and 11, So for 10, we're given 2 pi over 3, and we're finding the cosine of that. Remember, the cosine is x value. So 2 pi over 3 is here. The x value on it is negative 1/2. For 11, we have the tangent of 5 pi over 4. So tangent is y divided by x. So we have 5 pi over 4, which is here. We're using the ordered pair negative square root 2 over 2, comma negative square root 2 over 2. So if we're dividing y by x, we have negative square root 2 over 2 divided by negative square root 2 over 2. Oops. These are going to turn into positives because a negative divided by a negative is a positive. Keep, change, flip. So negative square root 2 over 2 times 2 over the square root of 2. These are all going to cancel to become 1s. So this is just 1. And so where our directions restrict half, so that way we can work with section 9.1. So with 9.1, 1 and 2, we're telling whether each function is periodic, and if the function is periodic, we're giving the period. For number 1, you have a periodic function here because this constantly repeats itself. If it keeps going, it'll be the same thing over and over again. So this one is periodic, and then your period goes between these 2 points here and here. So 1, 2, 3, 4. Your period is 4. For 2, you do not have a periodic function because this here does not repeat itself. So this one is not periodic. For 3 and 4, we're using the graphs of sine or cosine as a guide and identifying the amplitude and period and graphing each function. So for 3, we have an a of the negative 3 and a b of the 4. So our amplitude is the absolute value of the negative 3, which is 3, and our period is 2 pi over 4, or 2 pi over the absolute value of b, which is 2 pi over 4, and that gives us pi over 2. So to graph this, our first point is going to be our origin. Then our last point within this period is going to be pi over 2. We're going to go half the distance. We're going to treat these as pi, 2 pi, negative 2 pi. So with these, I'm going to go up and down. So I'm going to have to go through this halfway point here. I'm going to go down to negative 3 first, and then go up to positive 3 next. And then I'm just going to keep repeating this. So I'm going to go all the way up and then come back down. And then we're just going to repeat this. So I'm going to go halfway and then a whole. So I'm going to go halfway between the half and the starting to go down to negative 3, halfway between the half and the whole to go up to positive 3. So go all the way down, all the way up, back down to the x-axis. Same thing. I'm going to go halfway, go all the way down to negative 3, halfway that, go up to positive 3. I'm going to go down, go up, go back to my x-axis. I'm going to draw that arrow so that way it continues. It lets me know that it continues. So I'm going to do the same thing on the other side. This one, I'm going to go up first, halfway, and then I'm going to go down. So I'm going to go up to positive 3, curve down to negative 3, back up to my axis, my x-axis. Then I'm going to go another period. I'm going to go up to negative 3, down to negative 3. Oops, we are going way too far down. All right, so we are going down to here instead. All right, so up to positive 3, down to negative 3, back to my x-axis. Same thing, I'm going to go up to positive 3, halfway between, then go down to negative 3, go back up to my x-axis. Keep doing this throughout my entire coordinate plane. And then I'm good. For number 4, we're given p of x is equal to 2 cosine 0.5x. So this is the same thing as 1/2 x, so it might be a little bit easier for you to do your period with. So your amplitude is the 2, or the absolute value of 2, which is 2. Your period is the 2 pi over b, which is 1/2, the absolute value of it, which is positive 1/2. So that's 2 pi over 1 times 2 over 1, so that's 4 pi. So we are dealing with cosine. We have an a of 2, so our first point is going to be at 0, 2. Our next point is going to be at 4 pi, comma 2. And then halfway between those two is going to be down at negative 2. So we're going to do the same thing. We're going to go to 8, and halfway between is going to be at negative 2. Go the other way as well. And then draw your line through your points here. For 5, we are working with g of x is equal to cosine x minus pi. So our amplitude is our a, absolute value of a, which is 1. Our period is 2 pi over the absolute value of b, which is 1. So that's just 2 pi. Your phase shift is the pi over 1, which is just pi over 1, which is pi. Your x-intercepts are going to be gotten by when we graph this, and then your maximum and your minimum values are dealing with your amplitude, so that's positive and negative 1. So dealing with cosine, we're going to start with 1. Our period is 2 pi, so we're going to go up to 2 pi comma 1. Halfway between those, we're going to be at negative 1. So this is going to be the way our line looks. So we're going to do the same thing. And just duplicate this throughout the entire coordinate plane. And continue it to the other side as well. So going down to negative 1, up to positive 1. Down to negative 1, up to positive 1. So your x-intercepts here are those values that go through your x-axis. So it's going to be halfway between 1 pi and that would be half pi. So we have half pi plus 2 pi times n for the x-intercepts. For 12, we have tangent 5 pi over 6. So 5 pi over 6 is here. Tangent is y divided by x. So we have the order pair negative square root 3 over 2, comma 1/2. So this is going to be 1/2 divided by negative square root 3 over 2. Keep change flip, so 1/2 times 2 over, or negative 2 over the square root of 3. Those 2's would cancel to become 1 and negative 1, so we just have negative 1 over the square root of 3. We're going to rationalize this denominator and multiply the top and the bottom by the square root of 3, so we get the negative square root 3 over 3. For 13, we have sine, so that's y of 315 degrees. So 315 degrees is here. the y value is the negative square root 2 over 2. For 14, we have cosine 225 degrees. So cosine is our x value. 225 degrees is here, so the x value is the negative square root 2 over 2. For 15, we have tangent 60 degrees. So the 60 degrees is here. So we are going to use the 1/2 comma square root 3 over 2. So we are going to do the square root of 3 over 2 divided by 1/2. Keep, change, flip. Square root of 3 over 2 times 2 over 1. So these 2's are going to cancel, and this is just going to leave us with the square root of 3 over 1, or the square root of 3. For 8, 7, these are those ones that you're adding 2 pi times n, where n is a whole number, or just 2 pi if it's tangent. So sine negative 1, so the inverse sine of negative square root 3 over 2. So we're going to find the negative square root 3 over 2 wherever it is. We have one that is y value here. And we also have one that is here. So we're going to take those radical, or those radians, so 4 pi over 3, and add 2 pi times n, as well as the 5 pi over 3 plus 2 pi times n. And those are our answers. For 2, we have inverse cosine of 1/2, so x is 1/2. So we have a x value of 1/2 here as well as here. So we're going to do pi over 3 plus 2 pi times n, as well as 5 pi over 3 plus 2 pi times n. I think this is questions that we have. For 3, we have the inverse tangent of 0. So y divided by x is 0. So y divided by x is 0. So think about this. Your y and your x have to be, so either way, if we look at this one, y divided by x, 1 divided by 0 is 1 over 0. Can you have 0 in the denominator? No. So you're going to have to do it to where it's 0 over 1 is 0. So this one is it. So 0 plus 2 pi. And then you also have the negative 1 and 0. So it's pi plus 2 pi. Now we can simplify these to be 2 pi and 3 pi for our answers. For 4, we have inverse sine of negative square root 2 over 2. So y is negative square root 2 over 2. If we look here, your y is the negative square root 2 over 2 here, as well as here. So we're going to have 5 pi over 4 plus 2 pi times n, as well as 7 pi over 4 plus 2 pi times n. For 5, we have inverse cosine of the negative square root 2 over 2. So x value is negative square root 2 over 2 is here, as well as here. So that's 3 pi over 4 plus 2 pi times n, as well as 5 pi over 4 plus 2 pi times n. For 6, we have the inverse tangent of the square root of 3 over 3. So this is going to be y divided by x is the square root of 3 over 3. So that means that your values that you're looking at is either the 1/2 square root 3 over 2 or the square root 3 over 2 1/2. If we do 1/2 divided by the square root 3 over 2, Keep, change, flip, that's 1/2 times 2 over the square root of 3. This is going to give us what we need because this is 1 over the square root of 3. And we have to rationalize that denominator. So this becomes the square root of 3 over 3. So we're working with this one, not this one. So the square root of 3 over 2, comma 1/2. So which values give us a positive? If the signs are the same, it gives us a positive. So we're looking for the pi over 6 as well as the 7 pi over 6. It's where they have the same signs. If we look at our next set of examples, so we have restrictions here. So remember, sine and tangent are the first and fourth quadrants, and cosine is the first and second quadrant. So sine, where is sine? Your y value equal to -1. Where is y equal to -1 in the first and fourth quadrants? So the -1 is on the y. On the y. The y is -1 in the first or fourth quadrants. So that's here. So it's just the 3 pi over 2 and the 270 degrees. For 8, we have the inverse tangent of the negative square root 3. So this is those 1/2 and the square root of 3's again over 2. I'm sorry, 1/2 and the square root of 3 over 2. So we're working with a negative tangent first and fourth quadrant. So we are working with the fourth quadrant here so that we have opposite signs. We end with a negative. And we are going to take this ordered pair here. If we did the negative square root 3 over 2 divided by 1/2, keep, change, flip. This is changed to multiplication. This becomes 2 over 1. These cancel, so that's just the negative square root 3. So this is the ordered pair that we're working with. So we are getting our answer from 5 pi over 3 and 300 degrees. For number 9, we have the inverse cosine of 1. So first and second quadrant where x is 1. X equals 1 in first and second quadrant. All right, so first and second quadrant where x is 1, that's just 0. So 0 or 0 degrees. For 10, we have the inverse sine of the square root of 3 over 2. So where is y equal to the square root of 3 over 2 in the first or the fourth quadrant? So the square root of 3 over 2 for y is here. So that's pi over 3 or 60 degrees. For 11, we have the inverse tangent of the square root of 3, the negative square root of 3 over 3. So first and fourth quadrant is going to be the fourth since it's a negative. The inverse tangent of negative square root of 3 over 3, we are going to use the square root of 3 over 2 and the negative 1/2. If we divided those, it's negative 1/2 times 2 over the square root of 3. We'd have to rationalize that denominator. So this one's going to give us the answer that we need. So this is the 11 pi over 6, 11 pi over 6, or the 330 degrees. And then for 12, we have the inverse cosine, so x is equal to the square root of 2 over 2 from the first or the second quadrant. So the x value is positive. It's going to come from the first quadrant. Square root 2 over 2 is here. We're working with pi over 4 or 45 degrees. So I'm actually going to go back to that first page